Acids are proton donors. All acids form hydrogen ions, H+, when dissolved in water. It is these hydrogen ions that make a solution acidic. Properties of acids. They turn blue litmus indicator paper red. They have a pH from 1 to 6. They have a sour taste. And they should be aqueous to show acidic property. One common example would include lemons, which contain citric acid. Other examples include HCl, hydrochloric acid, HNO3, nitric acid, and many more. The acids used in labs, hydrochloric acid, sulfuric acid, and nitric acid, are all strong acids. A strong acid is completely ionized when it dissolves in water. There are no molecules of the acid present. Weak acids are generally organic acids, such as citric acid and ethanoic acid. A weak acid is only partly ionized when it dissolves in water. There are a lot of acid molecules present, but very few ions. We can tell if an acid is strong or weak by measuring its electrical conductivity, pH, and rate of reaction with metals or metal carbonates. The electrical conductivity of a solution depends on the concentration of the ions present. The more ions, the greater the conductivity. A strong acid conducts much better than a weak acid of the same concentration. This is because there is a greater concentration of ions in the strong acid compared with the weak acid. A strong acid has a lower pH than a weak acid of the same concentration. This is because there is a greater concentration of hydrogen ions in the strong acid compared with the weak acid. A strong acid reacts faster than a weak acid. This is also because there is a greater concentration of hydrogen ions in the strong acid compared with the weak acid. Oxides are compounds of metals or nonmetals with oxygen. There are 4 types of oxides. We tell the difference between these 4 types by their typical chemical reactions. Number 1. Basic oxides. Most metal oxides are basic oxides. Many basic oxides are formed by the direct combination of a metal with oxygen. Basic oxides react with acids to form a salt and water, hence acting like a base. Basic oxides do not react with alkalis. Many basic oxides do not react with water, but those from group 1 and many from group 2 in the periodic table react to form a metal hydroxide. An alkaline solution is formed, which then turns the red litmus paper blue. Acidic oxides, number 2. Most non-metal oxides are acidic oxides. Many are formed by the direct reaction with oxygen. Acidic oxides react with alkalis to form a salt and water. For example, carbon dioxide plus sodium hydroxide becomes sodium carbonate plus water. Some acidic oxides react with bases such as metal oxides when heated. For example, silicon oxide plus calcium oxide when heated becomes calcium silicate. Many acidic oxides react with water to form an acidic solution. Neutral oxides, number 3. Neutral oxides, as their name suggests, do not react with acids or bases. They are neutral. Examples of neutral oxides include nitrogen oxide and carbon monoxide. Most are the lower oxides of nonmetals. For example, carbon monoxide is a neutral oxide, but carbon dioxide is an acidic oxide. Amphoteric oxides. The word amphoteric means both of them. Amphoteric oxides have both acidic and basic properties. The oxides of aluminum and zinc are examples. They form salts when they react with acids, and they also react with alkalis to form complex salts. CASCOW, C-A-S-C-O-W, is an acronym used to remember the reaction between acids with carbonates. Carbonates react with acids to form a salt, water, and carbon dioxide. The carbon dioxide bubbles off as a gas. For example, copper carbonate plus sulfuric acid becomes copper sulfate plus water plus carbon dioxide.
Bases are insoluble substances which can neutralize acids to form salt and water. Alkalis are bases that can dissolve in water. When they dissolve in water, they produce OH minus ions, and as a result, they're known as proton acceptors. They turn red litmus indicator paper to blue. Some examples of bases would be metal oxides and metal hydroxides, such as magnesium oxide and lithium hydroxide. When a metal reacts with an acid, it produces a salt and hydrogen. So we can look at the example of magnesium reacting with hydrochloric acid. When Mg is added to HCl, it produces a salt, which is MgCl2. In addition to this, hydrogen is produced. So to balance the equation, we would just add a 2 in front of HCl. When a base reacts with an acid, it produces a salt and water. So this is also known as a neutralization reaction. As we mentioned before, bases are metal oxides and metal hydroxides. So when a metal oxide reacts with an acid, such as magnesium oxide plus phosphoric acid, it will produce a salt, which would be magnesium phosphate. And the reaction also produces water, so H2O. We'd also have to balance the reaction after.
Thank you all for watching, and I hope you learned something new. See you soon.